And in case of homogeneous soil, under the effect of upward soil pressure, the footing bends in a dish shape form. Sorry. An isolated footing must therefore be provided by two sets of reinforcement bars. Okay? Placed on the top of the other near the bottom of the footing. In case of the property line restrictions, okay, kapag lumampas ang inyong footing with your property line and nakapasok siya to the property line of your neighbors, okay, the footing may be designed for eccentric loading or combined footing. Okay? So, yung in the edge of your footing that was designed, no, to prevent from exceeding to your property line, the footing will be moved to the edge of your property line. Doon lang siya sa property line mo. Pero yung kanyang poste, it would stay the same. No? Kung ang inyong poste ay tumama mismo sa property line, at ililipat mo ang inyong footing, the poste will would stay the same, no? And ang possibility na gagawin mo diyan to calculate the loadings, no? Or to calculate the effects, to determine the effects, then the loadings should be solved with eccentrically loaded. Or you can use a combined footing. Okay? So, in figure 11.1, nasa taas, it shows the square and the rectangular isolated footing. Okay. So, we go now to the depth of the footing. So, the depth of the footing which foundation should be carried is to satisfy the following considerations. There are so many considerations if you design footing for us that our footing design footing would be safe for our building. The first one is to ensuring the adequate bearing capacity. Okay? Paulit-ulit natin itong sinasabi yung kanyang bearing capacity. Okay? It should not exceed, no? So the stress should not exceed with the soil bearing capacity. Okay? The next one, in the case of a clay soil, no? Footings are to penetrate below the zone where shrinkage and swelling due to seasonal water changes are likely to cause appreciable movement, no? Gaya nga ng sabi ko kanina, if you put your footing on the water table, no? It can show some effects, no? Pero it would be a light effect or it could be a serious effect. Okay? The footing should be located sufficiently below the maximum scoring depth. No? Makikita natin mamaya dun sa next discussion natin of what depth to be considered, no? During the designing of the footing. No? Meron kasing minimum depth of the footing and then meron ding range nung kanyang footing, depth of footing. Okay? That the fourth one is the footing should be located away from the topsoil containing organic materials and also from unconsolidated materials such as garbage, no? So kapag ganyan, it could be the soil will be a what do you call that? Malambot. Malambot yung soil, soft yung soil para makapag-handle siya doon sa design footing mo. Okay? So, kailangan i-place mo siya, your footing should be placed away from these consideration, from these criteria. Okay? All footings shall extend to a depth of at least 0.5 meters below the ground level or the natural ground level. Ito na nga po yung sinasabi natin kanina na if you consider the depth or if you design for the depth of the footing, it should be zero point 0.5, below zero point 0.5. Okay? On a rock or such other weather resisting natural ground, removal of the topsoil may be all that is required. In such a case, the surface should be clean, no? Kapag may mga rocks or other resisting natural ground, kung ano yung mga distractions doon sa taas ng inyong soil, it should be clean, no? So that kasi makaka-epekto ito sa ating footing. Okay? So as to provide a suitable bearing. Okay. Usually, footing are located at a depth of 1.5 to 2 meters below our natural ground level. Okay. So the pressure distribution below the footing. So the distribution of soil pressure under the footing is a function of a type of a soil. So it is a relative rigidity of the soil and the footing. So, and the depth of the footing or the depth of the foundation at level of contact between the footing and the soil. Okay? A concrete footing on a sand will have a pressure distribution similar to figure 11.2. Andito yung distribution niya, oh. Dito sa baba. So, kapag nakasand, nilagay sa sand ang inyong footing, the distribution, it could be a concave upward with respect to the footing. Okay? Kapag nakalagay naman siya sa clay, it would be a concave downward. Okay? If sa normal lang na soil, nilagay ang inyong footing, it would be a equivalent uniform distribution. Okay? Yun na. So when a rigid footing is resisting on a sand soil, the sand near the edges of the footing tends to display laterally when the footing is loaded. No? So it tends to decrease in soil pressure near the edges of your footing. Kita nyo naman, mas malaki ang pressure dito sa kalagitnaan ng inyong footing kaysa doon sa edges or sa gilid ng inyong footing. Okay? So in figure 11.2 point B, it is a footing or the distribution under a footing on a clay, no? Sa clay naman siya. Gaya ng sabi ko kanina. Okay? And the footing is loaded, no? Kapag niloload na ang footing in a in a clay soil, so the tendency, the soil under the footing deflects in a bowl shape depression, no? Ito na yung concave downward niya, no? Relieving the pressure under the middle of the footing. For design purposes, it is a commonly assumed the soil pressure are linearly distributed. So mostly sa design, ito na yung kino-consider natin. In actual, it would be like this, no? Ganito yung kanyang distribution, yung letter A and letter B. But for designing, they prefer to use a linearly distributed pressure. Okay? The pressure distributed will be uniformly if the centroid of the footing coincides with the resultant of the applied loads as shown in 11.2. Okay? So, the next one, the ultimate bearing capacity. So, the ultimate bearing capacity is always denoted as QU. Q subscript U. No? So, we call it as a ultimate bearing capacity if the maximum density of a loading at the base of the foundation which causes shear failure of the soil, no? And then the other hand, the allowable bearing capacity of soil, it is the intensity of loading that the soil carries without causing shear failure and without causing excessive settlement, no? Kapag ang soil natin ay nag-cause or kapag ang foundation natin ay may cause of shear failure, it would be a ultimate bearing capacity, no? Pero kapag without causing of shear failure, no, or excessive settlement, it would be a allowable bearing capacity of soil, no? Kung ang ultimate bearing capacity is denoted as Q subscript U, sa allowable bearing capacity naman, it will be denoted as Q subscript A or Q subscript all. ALL, short, in short for allowable. Okay? So, it should be denoted QA in a service load stress. Mhm. So, the allowable bearing capacity of soil is obtained by dividing the ultimate bearing capacity, so yung QU mo daw, by a factor of safety over FS, yung tinatawag nila. So, therefore, yung ultimate bearing capacity mo in relation with the factor of safety, if the factor of safety is given, QU is equal to the QA over FS. Okay? Mostly the factor of safety that was given is ranging from 2.5 to 3. Okay? There is no unit for this factor of safety. Okay? So the allowable soil pressure for soil may be either gross or net pressure permitted on the soil directly under the base of your footing. Okay? The gross pressure represents the total stress in the soil created by the load above the base of your footing. So these loads, it would be include the column service loads, the weight of your footing, and also the weight of the soil on the top of your footing. So it could be derived as Q gross or the bearing capacity gross is equal to the bearing capacity of the soil plus the bearing capacity of the footing and plus the bearing capacity of the column. So if you sum up all this, it could be derived with the soil with would be the bearing capacity gross. Okay? For the moment and shear calculations, no, the upward and downward pressure of the footing mass and the soil mass get cancelled. No? For yun nga, they don't consider the moment and shearing calculations for this ganun. Pero in real life, there is a moment and these shearing effects. Okay? So the net soil pressure could get as Q net is equal to the Q gross minus the Q of the footing minus Q of the soil. Okay? So this figure would present the computations yung kanina na pinagbabanggit ko. Okay? The Q of the soil, i-add mo sa Q ng concrete, i-add mo sa Q ng column, makukuha mo si Q all gross or the Q allowable gross. Okay? Dito naman sa pangalawa, si Q allowable net ay makukuha mo siya kapag si Q allowable gross ay binawasan mo kay Q ni soil at Q ni concrete. Okay? The next one, the concentrically loaded footing, no? If the resultant of the loads acting at the base of the footing coincides with the centroid of the footing area, no, the footing is concentrically loaded and uniformly distributed of soil pressure is assumed to design. You can see it on this figure, no? Nandiyan na yung kanyang moment, ang kanyang eccentricity, which can be derived as the moment over the pressure that was applied. And then, kokontrahin naman siya sa baba ni bearing capacity. That could be the pressure over the area of your footing. No? Naintindihan ba? So, the magnitude of the pressure could be the Q is equal to pressure over the area or the load over the area. Okay. So, for designing of isolated footing, wait, okay. For designing of isolated footing is detailed in the following steps. No? Kapag magde-design ka ng footing, may kailangan kang steps na sundan or kailangan kang ay consider. Okay? The first one is to select the trial footing depth. Hanapan mo muna ng lalim or mag-isip ka muna ng kanyang lalim, possible lalim na 0.5 below the natural ground level, no? So, according to ACI code 15.7, the depth of the footing above reinforcement is not be less than 1.5 cm for footing on soil, no? And then nothing that 7.5 centimeter of its clear concrete cover. I know that you already know what this clear concrete cover has mean, no? Kasi it was always tackle or binabanggit ito during your reinforced concrete or in steel design maybe or in the soil mechanics one. I don't think so sa soil mechanics one. Okay? So, if concrete is cast against soil, the practical minimum depth is taken as 25 centimeters. So, medyo malalim na rin. Okay? So, yan na. To establish the required base area of the footing, no? Diyan mo na makukuha sa Q allowable net. So, saka na natin to i-ponder pa or palawakin pa natin yung knowledge natin diyan soon sa next discussions natin. Okay? So, to get the area, no, that was required, no, it could be derived as the load, the dead load plus the load from the life load over the allowable or the soil bearing allowable net. Okay? So the sa PD and PL, they are the service dead load and live load respectively. No? Sometimes you would use a 1.4, 1.6, 1.1, and 1.7. So, maintindihan nyo naman yan. I think you was applied in the design. No? Laging nilalagay yan sa design. Malimit lang nilalagay sa geotech. Okay? So, for L and B values, it would be possible to use a square footing. No? Mas mabilis na gamitin sa square footing because to achieve greatest economy. No? The third one is to evaluate the net factored soil pressure. No? Ayan na, si 1.2, 1.6, yan yung subscript na pinagbabanggit ko kanina with respect to the uh, dead loads and live loads. No? QU is equal to 1.2 PD plus 1.6 PL over length times B, or for square, it would be B squared. Okay? The next one is check the footing thickness for punching shear. No, yan yung iniiwasan natin, kalimitan, yung kanyang effects of the punching shear. No? Since the large soil are present under footings, high shear stress are produced, and since shear reinforcement is not normally used. Okay? So, yan na yung computations. Hindi na natin yan gaano itakal because it would be on your reinforced concrete. Ito na yun. Or sometimes it would be in your, I think, in your steel designing. Na gano'n niya ba to? Are you familiar with this formula, VC? The punching shear force. VC is equal to 0.53 square root of F prime C. Do you familiar ba kayo sa formula na to? Anyone? Familiar ba kayo? Hindi kayo familiar. So, siguro, anong topic nyo na ba sa reinforced concrete? Anong topic nyo na sa reinforced concrete? Wala. Hindi, nakalimutan nyo na yung topic nyo. So, I think sa last part ata ng RC to. No, yeah, the consideration sa columns, sa slabs, no? Yun. Columns, slabs, marami pa. Okay. So, the last one is to check the footing thickness for beam shear in each direction. So, yan na. Marami ng considerations yan. So, we will not ponder on these things na. Okay. So, before we go to the next, before we will go to the next topic, I will give time for your break. Break time muna. Saglit. We will back at 9 a.m. Hello again, students. Okay, we will move on to our next topic, the ultimate bearing capacity. Andyan ba ang lahat? Nakikinig ba ang lahat? Okay.
Yes, sir.
Yes, sir.
Okay, sige. Thank you. So, I will be showing again my screen. Oh, wait lang. Okay. Nakikita nyo ba?
Yes, sir.
Okay. Before we will proceed on this topic, do you have a questions from the past topic that we have studied or learned later before yung kanina? Wala naman. All clear ba tayong lahat?
Clear, sir.
Okay. I hope so na all clear tayo. Okay. So, the next one is the ultimate bearing capacity. So, lagi ito lumalabas sa ating dinidiscuss kanina and pag-usapan natin of what bearing capacity meant about. Okay? So, to perform satisfactorily, no? The foundation should have a two main characteristics. What are those main characteristics? Do you have an idea? Anyone from the class? Engineer Eljan, do you have an idea of what are, or just give me one main characteristics of a shallow foundation?
Sir, hindi po siya yung malalim masyado po. So, hindi masyadong, hindi masyadong mahaba yung length po ng tubig.
Okay, thank you. Meron pa bang gustong dumagdag? Okay, so parang wala na. So, these are the two main characteristics of the shallow foundation so that we consider it a satisfactory or safe, no? It's a safe. So, yun nga, they have to be safe against overall shear failure, okay, in the soil that supports them, no? And the second one is they cannot undergo an excessive displacement or excessive settlement. Ayaw nating mangyari yan. Yung sobra-sobra yung kanyang displacement at lalo na ang sobra-sobra ang kanyang settlement. No? So, the term excessive is a relative. No? Why? Because the degree of settlements allowed for a structure depends on a several conditions. No? So, a shear failure is also called as the bearing capacity failure. No other term, yeah. And it occur when the shear stresses in the soil exceeds the shear strength of the soil. No? So, there are some types or three types of shear failure. Yung isa, nabanggit na natin to kanina sa first discussion natin, which is the punching shear failure. Okay? The other two is the general shear failure, and the other one is the local shear failure. Okay? We will be talking these three types of shear failure later. Okay? So, what is the general concepts of this shear failure or the bearing capacity failure. Okay? Oh, you observe the figure in your screen. No? So, anyone from the class who can describe the figure on figure 3.1A? Anyone from the class? Or shall I call me Engineer Rivera? What is your observation about the figure 3.1A? Oy, nag-left si Rivera, apay. Natakot? O, Engineer Bueno. Engineer Bueno. Engineer Bueno. Are you there? Mukhang wala si Engineer Bueno. Punta tayo kay Engineer Padua. Engineer Padua.
Sir.
Oh, what is your observation about the figure 3.1A dito sa taas? Dito. Ano yung observation mo dito? All your answers naman ay is accepted naman. Kasi it is just a opinion naman siya. So go, Engineer Padua. Okay, thank you, Engineer Padua. Okay. So, uh, for this figure, we consider a strip foundation with a width of B. Ito, yung nakikita nyo. Ito yung mga width niya nasa taas. So, I've I have said before that yung kanyang width is not denoted as W or L. It is always denoted as letter B. Okay? So, consider it with a B resting on a surface of a dense sand or a stiff cohesive soil, no? Yun yung nasa figure 3.1A, yung nakikita nyo. So, if the load is gradually applied to the foundation, the settlement will increase. 'Di ba? Ito yung kanyang settlement. Kapag ang load natin ay lumalaki, yan ang kanyang settlement. Tignan yung figure na to, no? If you gradually increase your load or your unit area, your settlement will increase. Okay? So, the variation of the load per unit area on the foundation or so-called as the Q or the bearing capacity with the foundation settlement is also shown in 3.1. Okay? At a certain point, when the load per unit area equal to the a sudden failure in the soil supporting the foundation will take place. Okay? And the failure surface in the soil will extend to the ground surface. Okay? So this load per unit area is usually referred to a ultimate bearing capacity. No? Yan yung sinasabi natin kanina of the foundation. So when such sudden failure in soil takes place, it is called as general shear failure. So yung ating figure 3.1A, yan yung kanyang general shear failure, no? In figure 3.1B, no? it is considered rests on a sand or a clay soil of medium compaction. Okay? An increase in the load on the foundation will also be accompanied by an increase in settlement. O, tignan nyo yung figure ni settlement niya. If you will gradually applied a load, no, per unit area. Ayan, oh. Okay? However, in that case, the failure surface in the soil will gradually extend outward from the foundation. Hindi kagaya ni general shear failure. Okay? So, when the load per unit area on the foundation equals to the movement of the foundation will be accompanied by the sudden jerks. Okay? So, considerable movement of the foundation is then required for the failure surface is in soil to extend to the ground surface. No, makikita natin 'yan sa broken lines. Ito 'yun. Ito yung sinasabi ko, mga broken lines na 'yan. Okay? The load per unit area at which this happen is the ultimate bearing capacity. No? So, beyond that point, no, an increase in load will be accompanied by a large increase in foundation settlement. No? Kapag umi-increase yung kanyang load, umi-increase yung kanyang settlement. So the load per unit area of the foundation is referred to as the first failure load. Yun yung kay VESIC 1963. Ayan o. VESIC 1973 should I say. Okay. Note that a peak value of Q is not realized in this type of failure, which is called as the local shear failure. Yun yung sa letter B na. Okay? If the foundation is supported by a fairly loose soil, the load settlement plot will be the one in figure 3.1. C. Yun yung sa letter C na. Okay? In that case, the failure surface in soil will not extend to the ground surface. No? Beyond the ultimate failure load, the load settlement plot will be steep and practically linear. So that type of failure is also called a punching shear failure. Okay? Naintindihan ba? So, there are two types of there are two types involving the soil bearing capacity, which is the one is the Terzaghi bearing capacity, and the second one it is the Marioff bearing capacity. For now, we are dealing with the we are dealing with the uh, Terzaghi's bearing capacity. Okay? So, what is the Terzaghi bearing capacity meant about? So, the Terzaghi 1943 was the first to present a comprehensive theory for the evaluation of the ultimate bearing capacity of a rough, shallow foundations. So, according to his theory, a foundation is a shallow if its depth is less than or equal to its width, no? Parang yung kanina na-discuss na natin yan about the shallow foundation and yung kanyang ganun. Okay? Which is, he suggested that the foundation will equal to 3 to 4. Their width may be defined as the shallow foundations. Okay? And then, he add that or he suggested for a continuous or a strip foundation whose width to length ratio approaches to zero. Okay? The failure surface in soil at ultimate load may be assumed to be similar to that shown in figure 3.5 later. Note that this case of general shear failure as defined in 3.1a. So the effect of soil above the bottom of the foundation may also be assumed to be replaced by an equivalent surcharge, where is a unit weight of soil. No? So the failure zone under the foundation can be separated into three parts. Okay. Next one. You observe this one. It is the bearing capacity failure in soil under a rough, rigid, continuous, or a strip foundation. Okay. So the width of the footing is denoted as the B. The load, it is the ultimate bearing capacity. The DF, it is the depth of our footing. No? Take note that the bearing capacity can derive as the gamma times the depth of the footing. Wherein the gamma, it is the unit weight of the soil. No? We also consider its cohesion and its friction angle. Take note of this. Friction angle yung phi apostrophe na meron. And the cohesion. Okay? So, using equilibrium analysis, no? Terzaghi expressed the ultimate bearing capacity in the form. This is the general form. Okay? So, the ultimate bearing capacity can derive as the C and C. Okay? Wag niyong ganun yung C apostrophe. Yung apostrophe sa taas. Wag niyong pansinin. So, C and C plus Q and Q plus 1/2 or 0.5 gamma B and gamma. This will be used if the foundation is a strip or a continuous foundation. Okay? Wherein the C, I have said before, it is a cohesion of the soil. The gamma, it is the unit of the soil. And the NC, NQ, and gamma, they are the bearing capacity factors. No? Uh, it could be determined if the friction angle would be uh, identified. Okay? Nasa table lang naman yun mamaya. Later, I will show you. Okay? So, to estimate the bearing capacity or the ultimate bearing capacity of a square and circular footing foundations may be respectively modified to, no? So hindi lang siya strip footing or the what do you call that, continuous footing. Terzaghi also introduced the square footing and the circular footing. For square footing, it would be the ultimate bearing capacity is equal to 1.3 CNC plus QNQ plus 0.4 gamma BN gamma. So, ang pagkakaiba lang nito ay yung kanilang mga coefficients. Okay? For strip footing, the coefficients are 1, 1, and 0.5. Okay? For the square footing, the coefficients are 1.3, 1, and 0.4. Okay? Sa kanyang circular footing naman, it would be ultimate bearing capacity is equal to 1.3 CNC plus QNQ plus 0.3 gamma B and gamma. No? So, si square footing, ang pinagkaiba niya lang ay yung coefficient ni gamma B and gamma, which is 0.4 kay square footing at 0.3 naman kay circular footing. Okay? Ito ay na-derive sa mga formulas. We would not derive it more because napakahaba ang derivation nito. Baka it can took us a 2 sessions or 3 hours like that to derive from one equation lang. Okay? Do you have any question with these formulas? May question po ba? May question po ba?
Answer.
Okay. I hope so. So, moving on. So, take note that for square, the B equals to the dimension of each side of the foundation. Okay? And for circular, the width B equals to the diameter of the foundation. Okay? Alalahanin nyo yun. So, this would be the datas to determine the coefficients or the corresponding bearing capacities. Okay? Nandyan yan. Basta si phi, kapag given si phi, mahanap mo na si NC, NQ, and N gamma. For an example, if the friction angle is given as 21 degrees, no? Ang kanyang NC ay 18.92. Okay, nasusundan. Ang kanyang NQ ay 8.26 at ang kanyang N gamma ay 4.31. Okay? And so forth na yan. Yan, basta nandiyan na yung given. During your quizzes, siguro, ibibigay ko naman yan. And then, for your exam, may bibigay naman yan. Okay? For foundation that exhibit the local shear failure mode in soil. So, Terzaghi suggested these modifications. So, mag-iiba na. Mag-iiba na yung formula ninyo or yung equations ninyo kapag ang ginamit na ay local shear failure compared to the general shear failure. Okay? So, for local shear failure, these would be the equations. For strip foundation, it would be the ultimate bearing capacity is equal to 2/3 CNC plus QNQ plus 0.5 gamma B and gamma. Okay? Okay. So for square and for square foundation, it would be 0.867 CNC plus QNQ plus 0.4 gamma B and gamma. Okay. And for circular foundation, it would be 0.867 CNC plus QNQ plus gamma B and gamma. Okay. So, dyan nyo napapansinin si cohesion na may subscript. Subscript daw. May tawag dito, apostrophe sa taas. Okay. That's speaking of a local shear. Okay? So, ang pagkakaiba niya lang ito sa general shear, it would be the coefficients again of the bearing capacity, NC, NQ, and N gamma. And also, the coefficients nung nakalapit dun sa equation na yun. Like 2/3 and 0.5. Wala naman pinagkaiba dun sa 0.5, sa 0.4, at 0.3. It would be the same to the general shear failure. Okay? And yung nasa gitna, it is a Q and Q. 1 lang yan. Okay? Wait. Scan ko lang yung... Okay. So next meeting, I would tawag dito, expand kung ano talaga yung mostly used na name ni CNC, QNQ, and Gamma B and Gamma. May ginagamit diyan na tawag dito na terms para sa ganun during your college days pa lang alam nyo na. Kasi it is mostly used, no? Popular siya sa board exam, no? Yun ang sinabi ni yun ang laging sinasabi. Hindi niya sinasabi na what is the CNC, what is QNQ, what is gamma B and gamma, no? Ah, tignan ko mamaya, nakalimutan ko na kasi kung ano yung tawag diyan. Meron yung overburden pressure, the cohesion pressure. Siguro ang pagkakaalala ko diyan, ang overburden it is the Q and Q, and the cohesion pressure it is C and C. Hindi ko na maalala kung ano yung Y, gamma B and gamma, no? So sorry for that na hindi ko pa mamasabi ngayon, and i-clear ko yan sa inyo next meeting. Okay? So, kung ang general shear failure ay may table to determine the different coefficients of the bearing capacity, meron naman din kay local shear failure. This one, no? Mag-iiba siya. So that one. So if the friction factor is a 0, the corresponding coefficient of NC, NQ, and NY are 5.7, 1, and 0 respectively. Okay. Do you have any questions, Jaan? Wala naman. Okay. The next one is for the factor of safety. As I discussed earlier, na ang kanyang Q allowable is equal to the Q ultimate or the bearing ultimate over by factor of safety, no? So ang factors of safety is always hindi naman kalimitan, ang range niyan ay from 2.5 to 3. Okay? However, some engineers prefer to use a factor of safety such that mas prefer nilang gumagamit sila ng factor of safety. Upang sa ganun, the ultimate bearing capacity is defined as the ultimate pressure per unit area of the foundation that can be supported by the soil in excess of the pressure caused by the surrounding soil of the foundation level. Okay? So, if the difference between the unit weight of concrete used in the foundation and the unit weight of soil surrounding is assumed to be negligible, then ito ang mangyayari sa kanya. Ang kanyang ultimate bearing capacity net is equal to the ultimate bearing capacity minus the bearing capacity. Okay? And ang kanyang Q ulit, ang kanyang bearing capacity is denoted is can be get by or derived by gamma or the unit weight times the depth of the footing. Okay? So, the derived formula for that is the Q allowable or the net ultimate bearing capacity allowable. It is equal to the Q ultimate minus the bearing capacity over the factor of safety. no? So ginamit na nila si factor of safety. Okay? So, do you have any questions regarding that before we move on to our first problem? May question ba?
None, sir.
Okay, I hope so. So, for the first question, okay? Engineer Pamitan, can you read the question, the problem?
A square foundation is 2 meters by 2 meters in plan. The soil supporting the foundation has a friction angle of 25 degrees and 20 kilonewtons per square meter. The unit weight of soil gamma is 16.5 kilonewtons per cubic meter. Determine the allowable gross load on a foundation with a factor of safety of 3. Assume that the depth of the foundation is 1.5 meter, that general shear failure occurs in the soil.
Okay, thank you, Engineer Pamitan. So, ano ang ating hanapin dito? It is the allowable gross load. Tama ba? Tama ba ako? Or the net allowable load. Ano yung hanapin natin? So, ano yung hanapin natin? Engineer Jan, andyan ka ata? May gusto kong sabihin?
Yung allowable po, sir.
Okay. So, it might be thinking for you na paano natin gagamitin yung formula? Ano yung gagamitin natin formula, no? Kapag ganito, it would be a general shear failure or a local shear failure. At kailan natin gagamitin yung local shear failure, sir? Kailan natin gagamitin yung general shear failure, sir? No? So, mostly in the problems, they are specified to use a specific shear failure. Like this problem, we the problem is helping us to use the general shear failure. Okay? Pero kung hindi naman sinabi kung anong failure siya, and then nakita natin na merong apostrophe, si friction factor, at si cohesion, and then it could be we use as the local shear failure. Okay lang? Okay lang ba? Naintindihan?
Yes, sir.
Okay. Naiintindihan mo ba, Engineer Adon?
Yes, sir.
Engineer Adon, naiintindihan mo ba?
Yes, sir.
Okay. Engineer Frase, naiintindihan mo ba?
Yes, sir.
Okay. I hope naintindihan nyo yan. Okay. So, punta tayo sa painting. Andun yung ganyan. Ayan, ginawa ko na dati because this set 3 nag-solve na kami yesterday. Okay, nandiyan na yung problem. So this is the problem and this would be the illustration. Okay, the gamma, the unit weight of the soil, the depth of the footing, the width of the footing, since it is a square, it is 2 by 2. Okay, and then the Q, this would be the unknown, no? Kung ano yung allowable gross load na i-apply natin. Okay? So, ano yung kanyang friction factor? It is 25 degrees. Puntahan natin doon sa table. Ano yung corresponding ni 25 degrees? Nandito sa baba yun. Ayun. Kita nyo ba? Si 25 degrees, ang NC niya is 25.3. 13. Ang NQ niya is 12.72 and N gamma niya is 8.34. Sundan ba? Sundan ba? Nasundan ba? Okay, thank you. So, balik tayo dun. Nilagay ko na dyan. So, ang NC niya, nandiyan na, NQ and N gamma. And then, nilagay ko na rin yung width ng kanyang footing, which is 2 meters. The cohesion niya, it is 20 kilonewton per meter square. And its gamma, nilagay ko lang na Y, it is 16.5 kilonewton per meter cube. And its friction angle, it is 25 degrees. Okay. So, ano yung formula na gagamitin natin? It is a general shear failure. Ano yung formula ng kanyang square footing or square foundation? Ano yung formula niya? Anyone from the group? QU is equal to? Okay. QU is equal to? Ano yung formula natin na gagamitin natin?
1.3.
0.867.
Ha? Ano yun? $1.3 CNC plus
QNQ, sir.
QNQ plus 0.3 ba?
0.4.
0.4.
Okay, buti at naalala nyo. 0.4 gamma
BNY gamma, sir.
gamma B and gamma. Tama ba? Tama lang? Agree lahat?
Yes, sir.
Okay. So QU therefore is equal to 1.3 multiply natin kay C. Ano yung gano'n na ni C? It is 20 kilonewton. Tama? And then ang kanyang NC. Ano yung kanyang NC na? It is 25.13. 0.13. I-add natin kay Q and Q. Ano na yung Q? Ano yung ilalagay natin sa Q? Anyone from the group? Ano yung ilalagay natin sa Q?
Gamma times DF, sir.
Okay. Ano yung gamma natin? It is 16.5. Am I right? Tama ba?
Yes, sir.
16.5. Multiply natin siya kay the depth of the footing, which is 1.5. Okay lang? Multiply pa natin yung dalawa kay NQ. Ano yung CNQ natin? 12.72. Yesterday, nakakalimutan ko si NQ na ilalagay. And then, multiply, i-add natin kay 0.4 times gamma. It is 16.5. Multiply natin kay B. It is 2. It is 2. And then multiply natin siya kay, ano yung multiply natin kay n gamma, which is 8.34. So, ano yung magiging ganun natin, QU natin dito? Ano yung magiging QU natin dito? Anyone? Yan o. Ano yung QU natin dyan? Hello? Ano yung QU natin dyan? What is our QU? Engineer Malto, ano yung QU natin? Engine
78, sir.
Yes, Engineer Reyes, ano yun?
1078.29, sir.
29. Agree lahat?
Yes, sir.
Okay.
Yes, sir.
Ano yung kanyang ganon? Ano yung kanyang tawag dito? Unit. Ano yung kanyang unit? Agree ba ang ilalagay kong unit ay kilonewton per meter? Agree ba lahat? Kilonewton per meter? Tignan nyo yung problem. Yan o.
Yes, sir.
Meter ba? Yan o. Tignan yung problem. Observe nyo yung problem. Meter ba siya? O, tignan nyo na lang dito sa formula na to. Ang cohesion, it is kilonewton per meter squared times NC. No? Ano? NC, wala siyang ganun yan. Wala siyang tawag dito. Wala itong unit. So, ang unit ni ultimate bearing capacity ay kilonewton per square meter. Okay? Tama lang? Okay lang? Okay lang ba?
Yes, sir.
Okay lang ba? Clear?
Yes, sir.
Okay. So, ito na ba yung hinahanap natin? Yung 1078.29 kilonewton per meter square? Yan na ba yun? Engineer Kabhawatan, yan na ba yung hinahanap natin? Si 1078.29? Engineer Kabhawatan.
Hindi pa po, sir.
Why? Bakit hindi yan? Ano ba
Kasi
yung... Yes. Ano yun?
allowable gross po ang hinahanap.
Hindi ba ito yung allowable gross? Hindi pa ba ito yung si allowable gross? Guys, hindi pa ba ito yung si allowable gross? Okay. So, tama yung sinabi ni Engineer Kabawatan, no? Hindi pa ang hanapin natin is si allowable gross. Hindi pa ito si allowable gross kasi hindi pa tayo nag-subtract or hindi pa tayo nag-apply ng kanyang factor of safety. Okay? So it is a ultimate pa lang. Ultimate bearing capacity niya pa lang. Therefore, to determine its allowable, no? So Q allowable, the Q allowable is equal to the Q of ultimate divided by factor of safety. Tama ba? Tama ba yung formula? Tama lang ba?
Yes, sir.
Okay. So, ang QU natin, it is 1,078.29. At ang kanyang factor of safety ay 3. So, ano yung sagot dito? Ano yung kanyang sagot? Q allowable.
359.44.
359.5. Am I right? Tama lang ba?
43, sir. 0.43.
0.43.
Okay, for 3. Okay. Okay lang ba na ang unit niya is kilonewton per square meter? Tama lang ba?
Yes, sir.
Okay, kasi si factor of safety, okay, kasi si factor of safety ay walang unit weight, unit, wala siyang unit. Okay? Wait lang. Yung battery ng aking laptop is okay. Going back to our sa ating problem. Okay. So, ito na ba yung hinahanap natin? CQ allowable 359.43 kilonewton meter squared. Di ba? Hindi pa yan. Kasi ang nasa problem, it is stated na ang ating hanapin ay si allowable gross load. Load siya. No? So, kapag yan ang tinataatin, ang ating formula, we consider its area. Kanyang area. Ang footing area. No? So, therefore, ang total load or total allowable gross load can determine as Q, malaki, is equal to the Q allowable times, ano yung multiply natin sa kanya? Ano yung multiply natin sa kanya? Hindi ba ang kanyang area? Tama ba na ang kanyang area ang i-multiply natin? Hello?
Yes, sir.
Okay. Ang area ng square is equal to B squared. Therefore, ang Q natin is equal to 359.43 times the area, which is 2 times 2, 4. Okay? So the answer would be 1,430. Ano yung ganun nito? 37.9 ba yun?
72.
143 point. Ay, 1,000 for 3.
7.
7 point.
72, sir.
Okay, 72. Ano yung unit niya?
AN, sir.
Kilonewton.
Okay. Kasi nag-cancel na si area niya. Okay. Ito na yung kanya sagot. Yan. Yan ang kanyang sagot. Ganun lang namin. Inatawag dito. Ni-round up ko lang. 1,438 kilonewton. Okay. For the next problem, okay. Kita nyo ba? Kita ba?
Yes, sir.
Okay. Engineer Matthew Wee, can you read the problem?
A 2-meter wide strip foundation is placed at a depth of 1.5 meter within a sand clay, where C is equal to 10 kilonewton per square meter, where diameter is equal, angle is equal to 26 degree, and the gamma is 19.0 kilonewton per cubic meter. Determine the maximum wall load that can be allowed on the foundation with a factor of safety of 3, assuming the general shear failure. Use gross values.
Okay. Thank you, Engineer Wee. So, ano yung sinabi niya ulit sa problem natin? Ano yung gagamitin nating formula? It would be a general shear failure. Tama ba? It was stated in the problem. And then, ano yung formula ni strip foundation? Maalala nyo ba? Ito, kinuha ko na yung kanyang respective bearing coefficients para hindi na tayo pupunta doon sa kanyang table. So, what is the formula of a strip foundation? Maalala nyo?
CNC.
Okay. QU, or the ultimate bearing capacity, is equal to
CNC po.
CNC plus
QNQ, sir.
QNQ plus
1/2 gamma BNY pa.
1/2 or 0.5 gamma B and gamma. Okay lang? Okay lang. So, QU is equal to, ang cohesion na binigay is 10. At ang kanyang NC ay 27.09. I-add natin kay Q and Q, which is the gamma multiply the depth of the footing. Okay? The unit weight is 19. Tama ba? Ano yung nasa problem natin? Or 19.5? Tama, 19. And then, ang kanyang depth of footing ay 1.5. Okay lang? Okay lang ba? Okay. I-add natin siya kay 0.5. Tama? Which is the unit weight, 19. Multiply natin siya kay the B or the width of the footing, which is 2. And then multiply natin siya kay what do you call that? kay N gamma. May nakalimutan ba tayo sa kalagitnaan?
Sir, yung NQ.
Sir, yun NQ po.
Okay, buti napansin nyo yun. So, si NQ is 14.21. Careful of that. Okay? Si N gamma ay si 19.84. Wala na? May nakalimutan pa ba tayo? Okay na. All set. All set na ba? Okay. Kung all set na, ano yung ating QU? 800
62.85.
5 kilonewton per square meter. So,
Sir,
yes.
wala po bang 2/3 yung sa CNC, sir?
Si CNC kasi, it is a general shear failure, di ba? Tama? Going back, tignan natin. Ayan, di ba? Si continuous or si strip foundation. Baka ang tinutukoy mo ading ko ay yung si local shear. Baka ito yung tinutukoy mo.
Okay, sir. Thank you, sir.
Okay. So, ang nandoon sa problem, it was stated as the general shear failure. Okay lang? Be careful of that. Ha? Ingat-ingat kayo. Lalo na sa board exam nyo, baka mamaya, instead of local shear failure ang gagamitin nyo, baka ginamit nyo na ang general shear failure o vice versa. Okay? Any questions? May question ba? Okay. So, kailangan natin kunin din si allowable. Yung allowable niya, which is QU divided by its factor of safety. Okay? So, the ultimate bearing capacity would be 862.85 divided by the factor of safety, which is 3. Okay lang? Okay lang ba? Okay lang ba?
Sir, yung sa QU po,
Ano yung sa QU natin?
hindi po ba 795 po?
700? Ha? Hindi.
795 po.
Ito?
Yes, sir.
Sige,
0.35.
tignan natin.
Sir,
Yes.
sir, yung sa depth mo po ata, 1.20, 1.5 dapat.
Sorry. Oo pala. 1.5. Okay. Namali tayo ng in-input. Okay lang? So, na-derive na yung 862.
Yes, sir.
Okay. So, sorry doon, napindot ko lang yung 2 kanina. Hindi ko na napansin. Okay. So, going back to the allowable bearing capacity, okay lang to? So, tama na din to. 862 divided by 3. Tama lang?
Yes, sir.
Okay. So, ano yung sagot dyan? It would be 287.6.
6.
Okay lang? So, the unit of that is kilonewton. Kilonewton per square meter. Kasi, factor safety has no unit. Diba? So, to determine its maximal allowable load, which is Q, is equal to the Q allowable multiplied by its area. Okay? Ang area niya. Since it is a strip footing, no? So, 2 meters strip foundation siya, no? To. 2 meter wide strip foundation. Hindi siya kagaya ni square footing na the same ang kanyang width, B. No? So, it would be B times B lang yun. Or 2 by 2. 2 times 2 kapag square. Pero kapag si strip foundation naman siya, kapag walang ini-stated na length, you would default as 1. So, ang ibig sabihin nito, a 2 meter wide per length. Per meter length. Okay? Okay lang? Okay lang ba? May question doon? Hello? May question ba doon?
None, sir.
Okay. Kapag hindi ni stated, kapag strip foundation siya, na 2 meters, for example, it is a 5 meters wide strip foundation. Okay? So, ang gagawin nyo dyan, it would be a default as a per meter length. Okay? So, the area, therefore, it is a 2 times 1. Okay? So, Q, allowable, is 287.6 times 2 by 1. Okay lang? Okay lang ba?
Yes, sir.
Okay. So, ano yung magiging sagot na dito sa Q natin? It would be 575 kilo Newton. Okay. So, ito na yung ating solution. Kuha nyo ba yung 575?
Yes,
Kuha
sir.
ba? Okay. So, ang kanyang sagot ay 575. The Q maximum allowable. Okay? So, we will go na sa third problem. Yes? Meron ba? May katanungan doon? Okay. Engineer Ken Dangan, please read the last problem. Engineer Ken Dangan.
A design requires placing a square foundation at 1 meter to carry a column load of 1,500 kilonewtons per meter, where the soil properties are C prime is equal to 10 kilonewton per meter square, Phi prime is equal to 26 degrees, and gamma is equal to 19 kilonewton per meter cube. Determine the width of the foundation.
Okay. So, ang hanapin natin daw dyan, it is the width of the foundation. Question, what equation or what failure we would use? No? Ano yung failure na gagamitin natin for this specific problem? Anyone? Hello? Engineer Palataw. Ano yung ating gagamitin na failure for this specific problem? Engineer Palataw. Sige lang, try mo. Guess. I-guess mo lang.
Wala po akong idea, sir.
Ha?
Hindi ko po alam, sir.
Okay. Okay lang kung ganun. So, I've said before na kapag hindi siya stated na general shear failure or local shear failure, basta kapag ang binigay na properties ng soil ay merong what do you call that? May kalakip siyang apostrophe, it would be a local shear failure. Tama ba? Okay lang ba?
Yes, sir.
Okay. So, hinanap ko na din yung kanya. Sige, tignan natin, try natin. Si internal friction or the friction angle is 26 degrees. Try nating hanapin sa table. 26 degrees. So, ito na si 26 degrees. Sa taas yun. Ay, mali. Ayun. Kita nyo? Sa taas? Kita nyo ba? Itong nasa ganun ko, cursor ko, 626 sa taas. Sa right side, upper right side. Kita nyo siya? Ang kanyang NC ay 15.53.
Yes, sir.
Okay. At ang kanyang ganyan is 6.05. At ang kanyang wait. Okay. So, internal friction is 26. Wait lang, guys. Wait lang. Okay, going back. Sorry, yung magiging sagot dito pala sa problem na to dun sa PowerPoint ko ay I have considered na 24 degrees. Mali yung naisulat ko na 26 degrees. Pero we will use 26 degrees na lapak. Nabaguhin ko na lang yung aking answer mamaya. Okay? So, ang kanyang NC, lagay na lang natin. Ang kanyang NC equal to ang kanyang NQ equal to and ang kanyang N gamma ay equal to, kunin lang natin. Table na yan. So, 15.53, 15.53, 6.05, and 2.59. Okay. Wait. Pero sometimes, students, na kapag hindi siya stated and then wala siyang subscript, it is mostly, tawag dito, it is mostly a general shear failure ang ginagamit. Pero during the board examination, kung hindi nyo siya makuha ng tawag dito, kung hindi siya nyo makuha ng local shear failure, try nyo siya sa general shear failure. No? Yun lang naman din pagkakaiba niya. Pero most of the time, don't worry, based on my experience, these what do you call that? These bearing capacities are always given, no? Ay, sorry, 50.53. And then 6.05. Okay. Okay. So, ano yung magiging equation natin dito? Ano yung magiging gano'n natin? We consider it as a local shear failure. And it is a square foundation. So, ano yung ano yung formula niya?
0.867, sir.
May square foundation ba siya? Yung nakalagay dito? O, yan. Square foundation siya. So, we will go back to the square foundation, which is 0.867 CNC QNQ at 0.4 gamma B and gamma. Okay? So, QU is equal to, ano ulit yun? 0.867 C NC plus Q NQ plus 0. Ano na ulit yun? 4 or 3?
4, sir.
0.4 gamma B and gamma. Okay? So, ang QU natin, therefore, it is equal to 0.867. Ang kanyang cohesion, na it is 10. At ang kanyang NC ay 15.53. Okay lang ba? Q and Q. Ano yung kanyang Q? 18.5 multiplied by 1. The depth of the footing. 18.5, it is the unit weight of the footing multiplied by 1. The depth of the footing multiplied by its NQ, which is 6.05. Add natin kay 0.4 multiplied by the gamma, which is 18.5. Multiply natin siya kay the B, which is, yun yung unknown, yun yung ating hinahanap. Multiply natin siya kay N gamma, which is 2.59. So, ang QU natin therefore is equal to, ano yung QU natin? Ano yung QU natin? Hello? Ano yung QU natin? Tama ba na 218.62 plus
246.57 po yung una, sir.
246.57.
Yes, sir.
246.57. Agree ba lahat?
Yes, sir.
Okay. Plus natin siya kay
1.92.
ano?
1.92 B.
What?
Joke lang. Joke.
19 point
19.17.
17.
19.17, sir.
Tama? Okay lang? Agree doon?
Yes, sir.
Okay. So, ang next step natin is to determine its allowable by using its factor of safety. Okay? So, Q allowable is equal to 246.57 plus 19.17 B divided its factor of safety, which is 3. Okay? Therefore, ang sagot natin dyan ay 82.19 plus ano yung kanyang B?
6.39.
6.39 B. So, kunin natin ang kanyang area na ang kanyang width na by using its gross load, no? Or the applied pressure to the ground. Okay? Therefore, ang Q natin or the Q gross, it is equal to the Q allowable divided by its area, which is B squared because it is square. Okay? Kuha? Kuha ba? Kuha ba?
Yes, sir.
Okay. So, ano yung Q natin? Q allowable. It is divide ba to o multiply? Hello? Divide ba yan o multiply? Tignan natin sa kabila. It is multiply. Huwag niyong kalimutan yan, oh. Multiply siya. Tama ba? Multiply siya yan, di ba? Okay lang. Okay lang ba?
Yes, sir.
Okay, so it is multiply. Therefore, ang Q niya doon na load na binigay sa problem, it is 1,500. It is the column load, no? Kilonewton per meter. So, 1,500 kilonewton per meter squared divided by its B, which is, yun yung hinahanap natin, B squared. Okay? Equal natin siya kay Q allowable, which is 246.5, wrong. Q allowable pala is 82.19 plus 6.39 B. So, ano yung ating B? Ano yung kanyang ganun na? B. Anyone? Ano yung kanyang B? Hello, ano yung kanyang B na? Hello? Ano yung kanyang B?
$3.76,
3.70 758, tama ba? 758 or 76 meters. Okay. So, yan yung kanyang width or ang kanyang width, no? So, ganyan lang naman umiikot yung terzaghi, no? Just to all you have to do is to familiarize yourself with the equations, especially kung ano yung gagamitin. It's either the general shear failure or its local shear failure. Okay? So, yun lang. No? So, kapag hinahanap yung tawag dito, kapag hinahanap yung kanyang dimensions, it would be the design. No? Kailangan mong i-design. Pero, kapag hinahanap naman yung load, it would be the tawag dito, actual ata yun, yung word na yun. So, it is the design and hindi ko na maalala kung anong word. So, may questions ba regarding the solutions or regarding the topic for today? May question ba?
None, sir.
Okay, I hope so. The copy of this presentation and also the solution or the solving, I would tawag dito, post it into your LMS within this week. And then by next week, the first hour, we shall have a sit work. Sit work lang, madali lang naman siya, no? And then mag-lesson ulit tayo. And regarding your makeup class, which do you prefer na kailan tayo mag-makeup class? Pag-usapan na lang natin sa GC to. Okay lang? Okay. So, if you don't have any questions or tawag dito or suggestions or clarifications regarding our topic for today, then ayun. So, ang ipopost ko sa ating LMS, yun yung nandito na lapa sa ganun. Nagiging solution niya. So, before I will end, gusto kong iwan sa inyo itong tawag dito, quote. No? So, what the mind can conceive and believe, the mind can also achieve. Okay? Nasa inyo na yan kung ano yung inyong pinaninindigan at inyong pinaniniwalaan hanggang tawag dito, hanggang sa inyong future journey sa board exam especially, and ma-achieve nyo yung gusto nyo achieve high. Okay? Okay. So, if we don't have any questions, we will have our closing prayer. Okay? So, may I invite everyone to have our closing prayer. Okay? In the name of the Father, and of the Son, and to the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in beginnings, now, and ever shall be, world without end. Amen. Okay, thank you again, students. See you next time. And I wish best luck or good luck sa inyong prelim exam. No? Kaya nyo yan. And basta, do your best. Makaka-graduate din kayo on time. And I'm praying for you na lahat kayo on time makaka-graduate. Okay? So, if you don't have yan nga, lagi kong sinasabi, questions, you can leave the meeting now. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir.